All right, let's look at a second one here. So let's look at our given statements. It says that RT bisects SV. So let's look over here. RT right here is bisecting SV, this one. So it's cutting SV in half. So we could mark that this side has to be congruent to this side, SQ to VQ. All right, and then if you read the second given statement, it says the same thing in reverse. It says that segment SV bisects RT. So here's SV, and it's bisecting RT. It's cutting RT in half. So I could also mark this side congruent to this side. So make note, I didn't do just a single tick mark for all of them because I don't know if they're all congruent to each other. I do know that this side and this side are congruent, and then these two sides are congruent. Okay, just a little side note there. All right, and we want to prove that the two triangles are congruent by some method. So let's add anything else to the picture that we can. I noticed that anytime we have intersecting lines, we have vertical angles, so I'm going to make note of that. Okay, and since I have that, I can now say that I have a side, an angle, and a side congruent to a side, an angle, and another side. So we're going to prove this by side, angle, side. So we know that's going to end up being our last step down here. All right, so let's go ahead and let's start with one of our given statements. That's always easy place to start. So we've got RT bisects SV, and that is because it is given. All right, and RT bisecting SV, let's look at that again. That told us, therefore, that this segment SQ is congruent to VQ. So let's write that next. SQ has to be congruent to VQ. So what would our reason be for that? Well, that would simply be the definition of a bisector, a segment bisector. If we know something gets bisected, it cuts it into two equal parts. So for our reason, and you'll often have definitions for your reason. We'll say that's the definition of a bisector. Definition of bisector. Okay. Let's go ahead and if we notice that took care of one of our S's, we justified why one of the sides are congruent. Let's go ahead and look at the angle next. It doesn't really matter what order we go in as long as we hit everything and justify everything. So next we have these two angles that we marked. Now we can't just call them angle Q because you got two of them here. So let's say this could be angle SQR. Angle SQR. And that is congruent to, we could say, angle VQT. Okay, and we know that they are congruent because they are vertical angles. Vertical angles. Okay, that takes care of the A. Let's go ahead. We need to write our other given statement here. So let's do that next. We know that SV bisects RT because of given. Okay, so let's look at what that told us. SV bisects RT. So that cut RT in half, which means TQ is congruent to RQ. And that is also because it's the definition of a bisector. I'm shortening definition here, DEFN. Definition of bisector. All right, so that justified the other S. We justified every step, so now we can say that the triangles are congruent because of side, angle, side. UTV, reason, side, angle, side. And we're done with that one. Let's go ahead and look down at our third one here. Okay, let's mark anything we can because of the given statement. So it tells us that DB is perpendicular to AC. DB perpendicular to AC. So they're trying to tell us that we're dealing with right triangles here. Okay, I'm going to make note of that. We could draw that here if we want. There we go. Okay, and then AD is also congruent to CD. AD CD, marked them. And we want to prove the two triangles congruent by some method. So look in here, let's see, what do we know? Well, we're going to say those are right triangles because of our given. We also notice that the hypotenuses, I think that's how you say it, those two are congruent, and they share a side right here, also known as a leg in right triangles. So we could say that these are congruent by HL, hypotenuse leg. Okay, so that's how we want to prove this thing. Let's go ahead and let's start with our given statement. DB is perpendicular to AC. So with these ones, the ones where we have to use HL, they are a little bit more tedious because in your proof, you have to prove that you're dealing with right triangles in order to use hypotenuse leg. Okay, so you'll see what I mean here in a second. Let's go ahead and write down our first statement. DB is perpendicular to AC, and that is given. That's sloppy. Okay, so think about this. They told us they were perpendicular. Remember, you have to justify every single step in proofs. So because they're perpendicular, we know that angles 1 and angle 2 are right angles. So that told us angle 1 and angle 2 are right angles. I'm going to put RT. I'm going to shorten everything. Right angles. Okay, our reason here would be, well, that's the definition of perpendicular. If you have perpendicular lines, you know it makes right angles. So let's say that is the definition of perpendicular. I'm going to say perp. Okay. So this seems obvious to you, but you have to write down every step in proofs. So because we're dealing with two right angles here, we can now conclude that angle 1 is congruent to angle 2. So we'll write that as our next step. So we know angle 1 is congruent to angle 2, and it seems obvious, but you gotta write it. And our reason here would be, well, because we knew they were right angles, all right angles are congruent to each other. So our reason is all right angles are congruent. All right angles, let's see, are, this is not writing well. I'll just draw the congruent symbol. Okay, so we have officially established we're dealing with right triangles here. So we got to justify our H and our L, and we are done. Let's go ahead and do the H. Let's say AD, that's our hypotenuse, is congruent to CD. AD congruent to CD. And that reasoning was our given statement. Okay, so that takes care of our H, and then we can say that BD is congruent to itself. This is so hard to write on right now. BD congruent to itself, BD, and that is the reflexive property. Oh my goodness. Reflexive. And therefore, we proved everything we needed to. We can say the triangles are congruent because of HL. I'll let you write that last step there. You're just going to rewrite this statement right here. Let's look at one of these together on the back. So these ones are just a little bit different. At the top it says parts of triangles can be proven congruent once you know the triangles are congruent. The abbreviation CPCTC is used to prove that parts of triangles are congruent. Okay, so there's this big acronym we have in geometry called CPCTC, and that's what it stands for. So we can use this now in our proofs. So notice the proofs on the back here are different than the ones on the front because we're not proving the triangles are congruent. In fact, we're just proving that parts of the triangles are congruent. IF congruent to IH specifically, that to that. So you're basically going to do these the same because in order to prove the parts congruent, you first have to show that the triangles are congruent. Okay, once you show that the two triangles are congruent, then you can say, well, if the triangles are congruent, then these two sides have to be congruent because corresponding parts of congruent triangles are congruent, aka CPCTC. All right, so we're basically doing the same thing over here, except we'll just have one more step in the end where we use this CPCTC. All right, so let's go ahead and let's mark our givens. We got IG is perpendicular to FH, IG perpendicular to FH. So they're just trying to tell us that we're dealing with right triangles here. They also say angle FIG. FIG is congruent to HIG, so let's mark that. This one congruent to that one. All right, so what I see from here, and note, you cannot mark these congruent. That's what we're trying to prove. So you can't use that in the proof. I do know that they share a side right here. So I could say, I could prove these congruent by angle, side, angle. So in here, we're going to prove them by angle, side, angle. All right, let's go ahead and start with one of our givens. Really doesn't matter which one. I'm actually going to pick the second one, start with that one. Okay, we got to do angle, side, angle. That's going to take care of one of our angles right off the bat. So we're going to say angle FIG is congruent to angle HIG, and that is because it is given. This is writing terribly. Bear with me. Okay, given. All right, so that takes care of one of the A's in ASA. Let's go ahead and do the side. That one's easy. Let's go in order right here. We say side IG is congruent to itself. IG congruent to IG. I'm going to let you guys write it since this is not working out so well. That is because of the reflexive property. All right, that takes care of the S. And then we know to get our other angle down here, we're going to use that other given statement always. So let's go ahead and write that one. We've got IG is perpendicular to FH. I'll let you write the reason. That is because of given. And so let's see, they told us they're perpendicular, and what they're trying to tell us from that is that angle 1 and angle 2 are right angles. Angle 1 and angle 2, come on now, 2 are right angles. And again, I'll let you fill in why. That's the definition of perpendicular. Definition of perpendicular. And therefore, we can conclude that angle 1 is congruent to angle 2 because all right angles are congruent. Angle 1 congruent to angle 2. And your reason would be all right angles are congruent. All right, that took care of the other A. So now what we did is we proved the two triangles congruent. So let's go ahead and write that congruent statement. Triangle, we could call it triangle FIG if we want. FIG is now congruent to triangle HIG. And we did that by angle, side, angle. Angle, side, angle. Come on now. All right, and our very last step, because the triangles are congruent, then we can say these sides have to be congruent because of CPCTC. And that is our last step there. Okay, I think I might just let y'all write that. IF is congruent to IH. Write that in the last one. Because of CPCTC. There you go. Y'all try that next one on your own.